The European Space Agency's automated transfer vehicle continues to make its way toward the International Space Station right now. It's heading for a docking to the Zvezda module's aft docking port next Tuesday morning. The ship, which launched from French Guiana last week, is the fifth in a series of 5 vehicles that ESA, its member nations, and its industry partners have provided to the International Space Station project. Been delivering supplies to the station, but done a lot more than that as well over the years. Today, we're going to discuss that with Eric Van Der Wal, the European Space Agency's International Space Station Program Liaison in Houston. Good morning, Eric.
Good morning, Pat.
That was a beautiful launch last week. How have things been going so far?
Things have been going fabulous. We had a great launch on the 29th of July. Everything is going well. Systems are extremely healthy. And we're performing our phasing towards the ISS. It's slow and steady. All maneuvers are being completed as planned, so everything looks great for a docking next week, Tuesday.
Now, it's going to do some more work on the way, too. There's not just carrying cargo, but ATV has been a test bed for developing some technology, and you're going to try to demonstrate some of that on Friday with the liaison rendezvous sensors. Tell me what that is.
So basically, every ATV is similar to the previous one because certainly now it has become a mature concept. However, there is an experiment called LIRIS, stands for Laser Infrared Imaging Sensors, which is piggybacking on this last flight. We have sensors installed on the outside of the ATV and recording equipment on the inside. So maybe to give you an idea, the ATV today, his approach to the space station, is mainly done in a cooperative way. We have.
That is to say, the station is cooperating with it.
The station helps us. The station is aware that we're coming. We have, for the long-range approach, we're using GPS data, which comes from the ATV and from the space station, and we use RGPS navigation. And when we get closer, we switch to optical sensors, which work together with the space station, which has, on the SMF port, laser reflectors installed. However, ESA and the European industry believe that it's essential also to look at non-cooperative rendezvous. So, for instance, with space debris or objects which do not cooperate with you when you try to make an approach. So, new sensors have been developed for this new technology. LIRIS is one of them. So, LIRIS consists basically of an infrared camera, which will be used for a long-range approach, and a LiDAR for the short-range navigation. So LIRIS has been installed on the ATV, will be demonstrated on this ATV flight. There will be a fly-under at the end of this week, and we will use the data or use LIRIS and the sensors up to the rendezvous and the docking. LIRIS itself is not included in the navigation of ATV, so ATV has their own navigation system. LIRIS is just a separate thing. We will record the data, and once we get on board, we will get the recorders out, and then we'll bring the data down later.
It's very interesting. Now, in fact, on this flight, the ATV is also going to be used in sort of a similar way to demonstrate other technologies, but this is at the end of its mission. After it undocks 6 months from now, its descent is going to be different than what has happened before.
Well, one day the space station will have to come down. We call it the end of life of the space station. The space station is a very heavy vehicle, and unfortunately it's not plausible to have sufficient propulsion available to do a steep re-entry. Most vehicles will do a steep re-entry. The ISS is going to do, at its end of life, a shallow re-entry. Now, there is a crucial difference between a steep and a shallow re-entry. In a steep re-entry, you get very short but very, very strong heating on the vehicle, which has certain characteristics of breakup. On the shallow re-entry, you get a very slow heating, almost melting of the structures. So the ISIS partnership got together, has expressed a mutual interest to go and try to implement a shallow re-entry on the ATV in order to gather data to, as good as possible, model the future re-entry of the ISS. So we have agreed to that. So after our stay, which will be approximately 6 months, we will undock from the space station and get ready to do a shallow re-entry. There will be equipment inside the ATV. There will be an ESA experiment, which is a camera. This is a first. We will have eyeball, which is an infrared camera. We'll have rebar, which is a breakup recorder.
Right.
And then we will have also on ground, there is a great interest from people in Australia to have numerous experiments. I don't know the exact number, but it's close to 70 experiments which will do monitoring from the ground. And we will also ask, if possible, the crew from the space station, if we have the right lighting, to take pictures during the breakup of the ATV. And I think there will be a tremendous amount of data which we can collect from this reentry, and which will be extremely valuable to a lot of people, but especially the ISS.
Those are, I think, great examples of the kinds of things that ESA has been able to do with this project, and that's being turned over into future products or portions of future vehicles, right?
Well, we have to see that first. The European industry can be very proud. Can be very proud of what they have achieved. They have designed, they have developed, they have operated, or still operating, a fully autonomous, free-flying vehicle with, I would say, state-of-the-art navigation system and sensors. And we have done this now 5 times. At the same time, it has also proven that ESA, with the delivery of the 5 ATVs, we use those ATVs also as a compensation in kind for our parts or our obligation for the, I call it the household bill of the space station, so the common system operation cost. So with the delivery of Columbus module, which is attached to the station, and the ATV, it has also set ESA as a very reliable partner in international cooperation in human spaceflight. And I think this has led to rethinking what we wanted to do with ATV, because now that we have completed our obligation for the coming years, we were looking to a perspective to go beyond ISS. The ATV is surely limited to the resupply of the space station, and going beyond the ISS is the perfect way to reuse the technology, the processes and expertise that you have developed.
Some of those systems are going to be part of the next crewed vehicle, the Orion vehicle.
So when we looked at it, we have found something which we believe is a confirmation of the skills and the valuable partnership that ESA can offer. And we have signed an agreement with NASA to develop the service module of the multi-purpose crew vehicle of the Orion program. So this is again a confirmation, a validation of everything that ATV has brought to this program, has helped us do, all the expertise, and part of it is now being reused, not only technology, but the processes, everything will be reused in the development of this service module, which is part of a very important U.S. exploration program.
It's all very, very, very exciting to see what's going to happen with this in the next step. Eric, thank you for coming and sharing some of that story with us this morning.
Thank you so much, Pat.
Eric Van Der Wal is the your International Space Station Program Liaison with the European Space Agency's office here in Houston.